recap of what we did, you know, last class. You had the video, and then we recapped the class before this to kind of go through of the different graphs, visual representations, all that good stuff. So, what type of graph is this? Yeah. It is a histogram. Good. I'll show you right now. Histogram. Histogram. Okay. Approximately how many classes were pulled? And again, it's an approximation. So, what are we thinking? David, what is it? 105 classes. Good. And how'd you get that? Good. So the frequency of all of them. Excellent. So how many classes did practice together between 15 and 20 minutes? Nick, what was it? Okay, 15 and 20. So class time interval is here. So what would be 25? Maybe it was hard to see. How many of you had something different? Eleanor, what'd you have? 25. So looking at it, and again, when you copy another graph, it's really hard to see. So this is 5, 10, 15, 20, 25, and 30. Okay, so we have 25. Good. How many classes did practice together for over 30 minutes? Kaden? 15 classes. Good. Just include classes. Good. Okay, is this graph symmetrical, skewed left, or skewed right? I'm giving some people some time. Jaden? Skewed right. It's slightly skewed right. Okay, ever so slightly. Now, what's the relationship between the mean and the median? Catherine? Excellent. The mean is greater than the median. So anytime they're asking for the relationship between the two, if it's skewed one way or the other, it's going to be either greater or less than. That's the relationship between the two. If it's symmetrical, then the mean and median are the same. You should know. Yeah. Okay. All right. Then you polled kids in your neighborhood and asked them how many brothers and sisters they had. The graph shows the results. Answer the questions below. So what type of graph is this? Someone who has not answered. What is that, Grant? Dot plot. Good. It is a dot plot. How many kids were polled? Yep. 15 kids. Good. How many kids have over one sibling? Jax? 10. Good. How many kids have 3 siblings or less? Riley? 13. Good. Now, would you say this graph is symmetric, skewed left, or skewed right? Kaden? It's symmetric. Good. And what's the relationship between the mean and median? Kaylin? And can we take an estimate approximately what the mean and median would be? Yeah. 2. Okay, that's what it looks like. And you could also count to see where the center is. So you start, you end up somewhere in the 2 range. Okay? Could you go from the outer in? Great. Okay. Now we're looking at our box plot. This is the first time we see the box plot with an extreme outlier. Okay? The little star there represents the outlier. When asked to make a box and whisker, it is common practice to show an outlier as a little asterisk there and to include it in the whiskers of the box plot. Okay, so what's my 5-number summary? Someone who has not answered yet. Eliza. Excellent. Yeah, because it is an outlier and the maximum value. So that's where the kind of confusion is. Here on our 5-number summary, that will look like the maximum, but when you do it out in your calculator, that 80 has to show somewhere. So it is the maximum. However, that is our what? 80 is our what? Outlier. So where it says, are there any outliers? Yep. 80 would be it. Okay. And again, will you guys see, you might see this on some random questions whatsoever, but I really want you to understand what each of those pieces mean. Okay. The outlier will obviously be shown separately and be included in the maximum value. What is the range in the IQR of the data? So what is the range? Who has the range? Kip. 20. Okay, how'd you get it? Okay, right? So looking at it at first, if you didn't notice the star or even pay attention to it, because at first when I looked at it, I didn't even realize that was there, right? You would have gotten 20. So now that we see that this is the maximum, 80 minus 52, what do we get? Okay. And the interquartile range would be what? Kate? A little too much. How do we find the interquartile range? Eleanor? Good. So we take quartile 3 minus quartile 1. So quartile 3 is 63. And then quartile 1 is 54. So 63 minus 54 is 9. Good. Is the data skewed or symmetric? Skewed what direction? Right. Good. And remember, for box plots, skewness, you look at the median, okay? And you could also tell with the whisker. All right, what percent of hives brought in 56 or more pounds of honey? Zoe? 50%. Excellent. How about 63 pounds of honey or more? Kaden? 25%. Excellent. Because remember, from the minimum, right, to quartile 1 is 25%. Quartile 1 to the median is 25. This is 25, and this is also 25. All right. Now we look at Chicago and San Diego. Okay. Show the annual precipitation in Chicago and San Diego recorded over the last 30 years. Okay. What is the median amount of precipitation in Chicago? Charlie. 36.2. Good. How about San Diego? James. 10.3. Good. Which city has had more precipitation in the last 30 years? Christian. Chicago. Just because the totals are more. Okay. What percent of precipitation in San Diego is above 8.1? Let's see, Ryder. 75, good. How about D? At least 40.1 inches. Yep. 25%, good. What is the IQR in San Diego? Let's see, Campbell. Okay, so you had 12.8, right? Minus 8.1. Okay. Someone get something different? Catherine? 4.7. So I think that might have been 11 or whatever it was. So 4.7. You had the right idea. Which city has the higher quartile 3? Let's see. KR. Chicago. Good. Okay. Is it more common to have over 32 inches in Chicago or over 3.7 inches? Pearson. Why? Okay, good. As opposed to 32, there's how much? 75 from 3.7. What would it be? 100%. Good. And the key words here is over. Over. So it would be San Diego. Excellent. All right, and the last ones. What is the value of the third quartile shown on the box and whisker? KM. 10. Good. Okay. Then for number 2, math test scores of 20 students, what percentage of the test scores are less than 72? Gaden. 25. Excellent. Okay. So again, just a little recap of our visual representations. Okay. Were there any questions on the homework, the review that you guys had? Oh, there was a few. Number 7. There's a few that I saw question marks of in terms of shape, center, spread, right? Okay. So you would have had the min 3, quartile 1, 6, median is 12, quartile 3, 16, and the max is 21. Okay. So anytime it talks about shape, okay, what are your options in terms of shape? Catherine, what's one? Symmetric. Eleanor, what's another? Symmetric and skewed left. And obviously then we have skewed right. Okay? That's what determines the shape. Okay? Now the center, depending on a box plot, it's the median. Okay? On a normal curve, it would be the mean. Okay? The histogram would be the mean or median, depending. The center of the data is the median for box and whisker. The center of the data for histogram, typically you have to look at if it's normal, then mean or median. If it's skewed, then the median. Does that make sense? Same thing applies for the dot plot as well. Okay? And shape, center, and then spread looks at a few things. The IQR for box plots, the range, and the standard deviation. Okay, those are 3 things that describe the spread. Now, if you have a box and whisker, all right, the center is going to be the median. The spread, you're looking at the interquartile range. You could also look at the range as well. Okay, so when you are describing shape, center, spread, shape has to deal with symmetric or skewness. Center is your median and or mean, depending. And your spread is interquartile range, so the middle 50% or looking at the data as a whole. So if it's a small spread, then there's less variability. Okay, if the IQR is small, less variability. If the standard deviation is small, less variability. Okay, not a lot of movement going on. All right, so that's what it meant in terms of shape, center, spread. Spread for box and whisker Tell me what the IQR is and explain. Okay. Were there any other, I know that came up a few times. Okay. So if you take out your notes, okay, we're learning the last lesson today, which is 4.3. Which is page 17. Okay. This is where vocabulary comes into play. Okay. You're going to notice that the wording is going to be the same for a lot. Okay. Or repeated. So the population of a study is the entire set. So for example, the population would be all of those students. That's a population. A sample is a part of the population. So the junior class would be a part, would be a sample. This class would be a sample. Okay? Those are all little pieces of the entire population. So one thing, and it says it here, we could have a ton of different samples. We use sampling to make an inference about the population, because sometimes it's very hard to gather all that information. Okay, the bigger the sample and the more random, it's better for your study. Okay, bigger the sample, you have more coming in, and random is obviously the best. Okay, so we have to determine the population and then the sample. Okay, so looking at this first one here, the probability and statistics class is doing a study on how many hours students at Ludlow spend on TikTok during one day. They poll one class of each grade and collect their data. So what would be the population? Yeah, the school, right? So the population would be Ludlow. Okay. What's the sample? Yeah. Good. One class from each grade. Okay, so that's a piece of the entire population. Then number 2, your wrestling coach wants to sign up his team for a tournament over the first weekend in March. He polls the seniors to see if they are available to go before they ask the whole team. So, what is the population? The team. Population. The team. What is the sample? Well, seniors. Good. Again, part of the team. Okay. So we addressed the who we are collecting data from. Now we have to figure out the what. Okay. So when we're talking about the what, you have 2 things to look for: the parameter and the statistic. Typically, we are given the statistic. Parameter is measuring the entire population, but that can only be done if a census is run. How many of you have heard of a census before? Census. What is it? Those of you that have, the 2 of you that have. Yeah. Consensus. Yeah. A census is run every 10 years because it costs a lot of money. We actually just ran one. Okay. A census is run every 10 years through the government. It collects information on the population. So, your income, how many people are in your household, where do you live, all this sort of stuff. Okay. It's pretty invasive. They send mailings, they send emails, they do phone calls, whoever has a house phone anymore, but they They constantly do this research because it's run every 10 years, and that's how our numbers adjust by that data. Okay, so it's very, very hard and difficult to make assumptions or get exact values for the population because it's so large. That's why we use sampling. Okay, so one thing to keep in mind, parameter is about the population. Statistic is referring to the sample. Okay, so some of the key words that we're going to hear about is average, percentage, total number, okay, average time, gross movie tickets, all this stuff, all those words are going to be the same for both parameter and statistic when you describe it, okay? It does get very confusing. However, if you figure out the sample first, you can work backwards. Does that make sense? The statistic. Okay. So, often it's hard to measure the whole population, as I just said. So therefore, we don't have a parameter. However, sometimes it's given, and there's going to be examples of how it's given. The parameter might be an expression for what we are measuring. For example, percent of people, amount of time, average amount, okay, that sort of thing. Statistic will also have that actual numerical value, percent, average. It will match, okay? So here's one example. According to Snapple.com, because it's so reliable, as you could see, 13% of adults in the U.S. are left-handed. Okay. At Schools Administrators Conference, 16% of the adults attending were left-handed. So the population are all the adults. The sample were the adults at a conference, so a small piece. Now the parameter is 13% of adults are left-handed. Okay, so that matches this population. Okay, 13% are all left-handed. Now, out of this conference, 16% are left-handed. So this 16% supports the sample. Okay, now this was actually given to you. It's not given all the time. The parameter is not given all the time. So, if we look at this one, a random sample of 300 Ludlow juniors were asked when they go to bed during the school week. 85% of these students went to bed after 11. Okay, so what would the population be? Jaden. All Ludlow juniors. Okay, what would be the sample? Eleanor? 300 Ludlow juniors. So right now, looking at the population and sample, we have wording in common, correct? It's very similar. Okay. Now, what did we find out? What does that 85% represent? All Ludlow juniors or just the sample that was taken? David? The sample. So that means that is our statistic. 85% of the random sample went to bed after 11 p.m. So we're literally taking this statement and putting it for our statistics. Okay? So the hard part is the parameter. We're literally reiterating, taking out that percentage and replacing it with a word. Okay? So watch what the parameter is. The percent of all one idea would be the percent of all Ludlow juniors that went to bed after 11 p.m. Isn't it very similar? Instead of an actual percentage, we replaced it with the word, you could write out percent and just write it this way, of all Ludlow juniors. Okay? So the wording is very similar for parameter and statistic. However, the parameter is not always given. Okay? Let's try another one. Miss Betta wants to know if any students missed her during quarantine. Obviously, all of you would. She polls one of her classes and asks if they missed her, and 74% said that they do. Okay, so what would be the sample? Riley? Good. What is the population? Yeah. All Miss Sabetta's classes. So again, same wording. Okay. What can we do? What's our parameter? What's our statistic? Which one? Kate. Perfect. Excellent. Okay. And what's our statistic? Checks. Yep. Okay. So again, same wording, very similar. Okay. Very, very similar. Right? Try the next one on your own. Okay, try this next one. All right, let's go through this. Group of friends want to record how many ounces of water they consume during the day. 3 of the friends record their water consumption and learn that they consume on average 38 ounces a day. As a group, they also recorded and learned that on average they consume 43 ounces. All right, what is the sample? Kaden. Friends, good. Good. What's the population? Yep. Yep. Excellent. Okay. Parameter. Go ahead, Tommy. Is that the parameter or the statistic? Statistic. Good. So, average consumption, water. Okay. What is the parameter? Go ahead, Ryder. Yep. Good. Okay. So, when you're talking about population and parameter, yeah. The number. So you could change this and say the average consumption for the group was 43 ounces, but it's always a numerical value or some sort of average percentage, something like that, but it refers back to the population. Okay, statistic will always be a numerical value. Most likely it's always given to you, but it's based off the random sample, in this case the 3 friends. Okay, great question. So we have seen this a lot, this piece, okay, which is called the margin of error. Sometimes when you're given statistics, especially with polling, you will see it's plus or minus some number, right? Because they're giving you a range. There's some sort of error that happens, either with sampling, data error, whatever it is. We see it a lot with elections. So the margin of error is the likely error when the data from a sample are used to estimate a population characteristics. So the margin of error represents any erroring that can happen during sampling, okay? The margin of error tells us how close to our estimate. So the margin of error gives us a little buffer, okay, based off the statistic, okay? So we use this quick method in terms of margin of error, okay? Sometimes it's a little more intense to find the margin of error, but we always write it as a percent, okay? It's always plus or minus because you have an interval. So you're given a statistic, it's either below that statistic or above that statistic. Pretty much like standard deviation, how we did one above, one below. To find that, it's 1 over the square root of n, which n is your sample size. Okay? Now, one thing to keep in mind, the larger the sample size, the smaller the margin of error. Okay? The smaller the sample size, larger margin of error. So we always tell people when they're doing sampling that you want the bigger the sample because there's more variability, there's more consistency with that, okay? And it has to be random. So there's something called the confidence interval, and you guys might have heard it too. We are 95% confident that blah, 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 okay? That is a key statement that is used, all right? So how we find that out is you take your statistic and plus or minus your margin of error, okay, to find your interval. That's your confidence interval, which we are getting into, okay? So a recent poll found that 35% of Americans got their most recent news from social media, which is, that should be a little bit higher than that, I think. The survey asked about 2,078 adults in the U.S. questions about their media consumption. 95% confident was given for the conclusions. Okay, so what is the population? Grant. What's the bigger picture? What would be the bigger picture? Who's getting their news? Americans. So all Americans. Okay. What is the statistic? Yeah. You could even make that even, because here it says 35% of Americans, right? But then it says to adults. So we could include all American adults, right? Yeah. Good. Okay, what is the statistic? Yep. 35%. Good. What is the sample size? David? 2,078. Good. Now, we want to rate the margin of error as a decimal. So we use our little formula, 1 over the square root of the sample. So with the decimal, you want to round to 3 places. Yep. Look, they're asking for the statistics because it's based off of here. This is the poll found. So this imprint, this is what that number is representing. Okay? Great question, though. Great question. The poll found, because they're only surveying the 2,000 adults, 2,078 adults. Okay. All right. What is the margin of error? Yep. What is it as a decimal? God bless you. Okay. David? What did you get? Okay. 0.022 as a decimal, right? How would I write that as a percent? Kaden? 2.2%. Okay. Now, the interval. Okay, this is what it looks like. Anytime it says the confidence interval, it's going to be your statistic, 35%, plus or minus the margin of error. Okay, that's your interval. That's what it looks like. Or you could also do it out, which we're going to do right now. So in conclusion, we are 95% confident the percent of Americans, and it should be adults, getting their news from social media is between, what do we get? 35 minus 2.2. Eleanor? 32.8, and then 35 plus 2.2. Go ahead. 37.2. So this confidence statement is your conclusion, where you're subtracting the margin of error as well adding it. Okay, let's try another one. Okay. A survey reported 6.8% of the population smoked with a margin of error of 3.2%. So what is the actual range of these values? Yeah. To what? Okay, so we remember 6.8%, 16.8% is the statistic. Then we have to plus or minus the margin of error. Catherine? To 20%. Good. 16.8 minus 3.2, and then you have to add 3.2. Okay. What are some reasons why we have a range of values, not just a single percent? There's 26 of you, and the same people keep answering. So why? Can you put your hand down? Jax, put your hand down for a minute. Kaden, you too. What are some reasons why we have a range of values and not just a single percent? Jaden? Not so much outliers, but thank you for volunteering. Eliza? Okay, there could be some issues with answering some of the questions. Okay, what else? Kaden? So we don't know the exact amount. It's like an estimate. Yeah, Kate? Perfect explanation. All of you guys. Okay, that was just well said. Okay, the margin of error gives you that variability. There can be issues with the way the questions are asked, the way the data is taken, how truthful. Think of a survey, right? Or how about people that don't answer? Like when I get those survey calls, what do? I hang up. Like I don't want to talk to you. Like, it's very rude, but I have no time. Anyway, but like those sort of things happen, right? Think of the sampling, and some of you guys might have seen stat classes come in and do surveys for you guys, right? You've seen that. That's happening in the probability class, but there's people that might not answer truthfully. There's people that might not answer all the questions. So there is always variability. It's making inference about the population. So we're going to get as close as we can, but if there's 1%, it would be definite. And we can't do that with the population. Does that make sense? Okay. So now, a student gets a printout of PSAT diagnostic that say they are 95% confident that she will score between 540 and 600 on the reading and writing section. Okay, what is the estimate? So in parentheses there, it's the average of the interval. So what is the middle of the road between those two scores? Yeah, 570. And we get that 540 plus 600. Okay, so now the margin of error is the distance, okay, from the average above. So 570 to 600 is how much? 30. So that is going to be our margin of error, plus or minus 30. Okay, so to write this interval, it's the estimate, which we're going to get back to. So what we just did is we worked backwards. We were given an interval, and we worked backwards to get what it should be. Okay, they gave us the interval. The past two examples, we found that interval. Does that make sense? All right, so here we go. Broke up participants in two groups and asked both if they were bothered by seeing other people not recycle. Group A had 430 and Group B had 191. If 61% of both groups answered yes, they were bothered, what is the confidence interval for Group A? So 61% is what for both? It's our statistic, right? 61% is our statistic, our estimate. So what is our margin of error for Group A? Yeah. Yeah. 61% of Group A and 61% of Group B. Yeah. It ends up being the same percentage for both groups. Great clarifying questions. So what is the margin of error for Group A? How about this? What is the sample for Group A? Catherine, is that a hand? 438. 438 is the sample for Group A. So 1 over the square root of 438 would be what as a percent? David? 0.048, which is what as a percent? 4.8%. So your interval for Group A is 61% plus or minus 4.8%. That is your interval, confidence interval. So now we have our statement. Therefore, using Group A, we are 95% confident the true proportion of Americans would be bothered by seeing other people not recycle is between what two numbers? Grant, go ahead. Good. Excellent. Okay. Now you guys are going to do the same thing for Group B. Go ahead. All right. What is the confidence interval for Group B? Riley. Good. How many of you did get that? Okay, good. So, using Group B, we are 95% confident, blah, blah, blah. Bothered by seeing other people not recycle is between what? Kip. Good. So now, which group is more useful and why? Go ahead, Kip. Okay. Oh, Noella. You're correct. Okay, can someone build off of that? Yeah, well, correct. So group A is the better bet because the larger the group, if you guys just notice, the smaller margin of error. So there's not a lot of risk happening to the way we sampled, right? The more we sample, the smaller the margin of error, and that's what we want. Does that make sense? How many of you had group A? Okay, some of you might have not been sure. So one thing to keep in mind, if any takeaway for the margin of error, larger the sample, smaller margin of error. That's key, okay? The more we sample and the more it's random, the closer we'll be to the truth, okay? Yep. It was 1 over square root of 191, okay? And you should have gotten 0.07, was it 72? Yeah. And then multiply it by 100. And you multiply by 100, and it gives you the 7.2%. Okay, so your homework is in our packets, okay, that you can get started on now. You have 13 minutes, and I think all of you will finish this. On page 10, it's the 4.3 practice, page 10 through 12, so 1 through 12. 4.3 practice, starting on page 10 through 12, numbers 1 through 12. Okay?